The dawn of a new era in food production is upon us. The world watches as science pushes boundaries. One frontier is food. The way we grow, produce, and consume food is evolving rapidly. Genetically modified organisms, or GMOs, are at the forefront of this revolution. They represent a significant shift in agricultural practices. These are not products of traditional breeding. Instead, they are engineered with precision and purpose. They are born from labs, genes spliced with intention. Scientists meticulously alter genetic material to achieve desired traits. This new genesis sparks hope and fear. Can we solve hunger? The potential to address food scarcity is immense. Or will we unleash unforeseen consequences? The answers are complex and multifaceted. We must explore the science, the promise, and the perils of GMOs. Understanding both the benefits and the risks is crucial. This is an attempt to delve into the heart of the GMO controversy. It is a topic that stirs strong emotions and diverse opinions. Let's examine the science and the controversy. The discussions are heated and the stakes are high. Join me as we explore the potential and the pitfalls of this powerful technology. The journey is both enlightening and challenging. The future of our food system may depend on it. The choices we make today will shape the world of tomorrow. Decoding the double helix. The science behind GMOs. This journey into the microscopic world reveals the secrets of life itself. Imagine the intricate code of life. This code is DNA, a molecule that carries the genetic instructions used in the growth, development, functioning, and reproduction of all known living organisms. It dictates the traits of an organism, from the color of a flower to the height of a human. Scientists have learned to manipulate this code, unlocking the potential to alter life at its most fundamental level. They can insert genes from one organism into another. This is genetic engineering, a powerful tool that allows for the creation of genetically modified organisms, or GMOs. It is the foundation of GMO creation, enabling the development of crops with enhanced traits.
The process is precise, involving careful selection and insertion of specific genes. Scientists identify a desirable gene, one that can confer beneficial traits to the organism. This could be a gene for pest resistance in bacteria, which can then be transferred to a crop to protect it from pests. They isolate this gene and copy it, ensuring they have enough material to work with. Then, they introduce this gene into the DNA of a plant, integrating it into the plant's genetic structure. The plant now carries the new gene, which becomes a part of its own DNA. It expresses the desired trait, such as increased resistance to pests or improved nutritional content. For example, it may become resistant to a specific pest, reducing the need for chemical pesticides. This is a simplified view of a highly sophisticated process. The process is complex and constantly evolving, with new techniques and technologies emerging regularly. But the basic principle remains: targeted manipulation of genes to achieve desired traits, revolutionizing agriculture and biotechnology.
Bounty from the lab, unveiling the potential of GMOs. GMOs hold immense promise. They offer solutions to agricultural challenges. One key benefit is increased crop yield. GMOs can be engineered to resist pests. This reduces crop loss and increases productivity. Another advantage is enhanced nutritional value. Scientists can modify crops to produce essential nutrients. This can address dietary deficiencies in many parts of the world. GMOs can also contribute to environmental sustainability. Some GMOs require less water, or pesticides. This can have a positive impact on our planet. The potential benefits of GMOs are vast and varied. They offer hope for a more food-secure and sustainable future. Seeds of doubt, navigating the concerns surrounding GMOs. Despite the potential benefits, GMOs have sparked controversy. Concerns about their safety are paramount. Some fear that GMOs could have unintended consequences for human health. Long-term studies are ongoing to assess these risks.
The environmental impact of GMOs is another concern. Critics argue that GMOs could lead to the emergence of superweeds. These weeds could be resistant to herbicides, posing a threat to biodiversity.
Ethical considerations also fuel the debate. Some question the ethics of manipulating the genetic makeup of living organisms. Others worry about the control corporations have over the food supply.
What is it? Frankenfoods or future foods? Debating the merits of GMOs. The debate over GMOs is polarized. Proponents argue that GMOs are a safe and effective way to feed the world. They point to the rigorous testing and regulation of GMOs. Opponents, however, remain skeptical. They call for more independent research and stricter regulations. They advocate for the labeling of GMO foods, giving consumers the right to choose. The debate is complex and multifaceted. It involves scientific evidence, ethical considerations, and economic interests. Finding common ground requires open dialogue and a commitment to evidence-based decision-making. GMOs on our plates. A glimpse into the present. GMOs are already a part of our food system. They are found in processed foods, animal feed, and even clothing. Corn, soybeans, and cotton are among the most common GMO crops. Many of these GMOs are engineered for herbicide tolerance. This allows farmers to spray herbicides without harming the crops. Others are modified to resist insects, reducing the need for pesticides.
The prevalence of GMOs raises questions about labeling and consumer choice. Should consumers have the right to know if their food contains GMOs? This debate continues to unfold.
GMOs, golden rice, a beacon of hope, or a slippery slope. Golden rice is a genetically modified variety of rice. It is engineered to produce beta-carotene, a precursor to vitamin A. Vitamin A deficiency is a serious health problem in developing countries. Proponents of golden rice argue that it could save millions of lives. They see it as a powerful tool to combat malnutrition. Opponents, however, express concerns about its long-term effects and potential impact on biodiversity. Golden rice highlights the complexities of the GMO debate. It showcases the potential of GMOs to address critical health issues, but it also raises ethical and environmental questions that demand careful consideration. The regulatory maze, ensuring safety and transparency in the GMO landscape. The regulation of GMOs varies widely across the globe. Some countries have strict regulations in place, while others have more lenient oversight. This patchwork of regulations creates confusion and uncertainty. Consumers are demanding transparency. They want to know what is in their food and how it is produced. Clear and consistent labeling standards are crucial to build trust.
Governments and regulatory agencies play a vital role in ensuring the safety of GMOs. They must strike a balance between fostering innovation and protecting public health and the environment.
Public perception versus scientific evidence, bridging the GMO divide. Public perception of GMOs is often negative. This is fueled by misinformation and fear-mongering. Scientific consensus, however, supports the safety of GMOs. Numerous studies have shown that GMOs are as safe as their non-GMO counterparts. However, communicating scientific findings to the public can be challenging.
Bridging the gap between public perception and scientific evidence requires clear and accessible communication. Scientists, policymakers, and the media all have a role to play in fostering informed dialogue.
The future of food. Will GMOs feed the world? The global population is projected to reach 9.7 billion by 2050. Feeding this growing population will require innovation and sustainable agricultural practices. GMOs have the potential to contribute to food security. They can increase crop yields, enhance nutritional value, and reduce waste. However, GMOs are not a silver bullet. Addressing food security requires a multifaceted approach. This includes investing in sustainable farming practices, reducing food waste, and promoting equitable access to food. Conclusion: our call for informed dialogue and responsible innovation. GMOs are a powerful technology with the potential to address some of the world's most pressing challenges, such as food security, climate change, and sustainable agriculture. However, they also raise valid concerns that must be addressed, including ethical considerations, environmental impacts, and long-term health effects. Moving forward requires informed dialogue and responsible innovation, where all stakeholders are heard and their perspectives are valued. We must engage in open and honest conversations about the risks and benefits of GMOs, ensuring that the public is well informed and that scientific evidence is clearly communicated. Ultimately, the future of GMOs depends on our ability to find common ground, balancing innovation with caution and respect for diverse viewpoints. By embracing evidence-based decision-making and fostering transparency, we can harness the potential of this technology while mitigating its risks, ensuring that it serves the greater good. The choices we make today will shape the future of our food system and the well-being of generations to come, highlighting the importance of responsible stewardship and proactive engagement in the ongoing dialogue about GMOs.